This third lecture will be really useful to you when you walk into your first in-person lab, either this week or next week. So this lecture is entitled Measurements in Significant Figures, so let's talk about measurements. Okay, measurements. You'll absolutely be taking measurements in lab. Thankfully, we use measurements every day. First thing in the morning, when you step on the scale, you're measuring your weight. If you bake some type of recipe, you measure out ingredients using a measuring cup. When you drive your car down the freeway and you see a speed trap and you quick glance at your speedometer, you're measuring your speed at that moment. So in each of those examples, we have a different measuring tool. All of them have markings on them, which will prove to be really useful to us when we get to significant figures. Um, but those markings and these measuring tools is really what helps us understand the world around us by understanding these measurements in terms of useful dimensions that you and I can understand. So let's do some definitions. So a measurement is the experimental determination. When I say experimental, I mean we observe it. Determination of of a quantity of matter. So quantity of matter, I just mean any type of aspect of the matter. So I'm being vague here. You can measure many different aspects of an object, and that's what I mean here in this second point. A measuring tool is used to compare some dimension of an object to a standard. So, meaning we can measure some dimension, meaning we can measure the length, the size, the weight, the volume of an object, so some type of aspect or quantity to a standard. So usually this is where I mean we have to use units. Um, it's really important when you use a measuring cup that when you measure out, like, let's say 2 cups of flour, that your 2 cups of flour is the same as my 2 cups of flour when I measure it. So that's what I mean to a standard units. So all measurements always come with a number and a unit, so a value number and a unit. The unit is the most important thing. It's what standardizes the number. So my mom could ask me to go to the grocery store and buy some tomatoes. Well, I could ask her, how many tomatoes do you want? And she says five. Does she mean she wants 5 single tomatoes, or does that mean she wants 5 pounds of tomatoes? See how the unit there is very important when trying to convey information or even scientific information. I don't want to come home with the wrong thing. All right, so measurements always include a number and a unit, and it's always important to convey those things, a number and a unit, in scientific writing. Okay. So more on measurement. So we can measure many different dimensions of an object. So some that we will talk about in detail include length, volume, mass, time, and temperature. So those are the five different aspects that we can measure about an experiment or an object that we can measure in lab easily. We will be talking about all 5 of these different dimensions of matter in detail, but it's important to point out the units that go along with all of these different things that we can measure. Well, it depends on if I'm in a laboratory or if I'm just at home. If I'm at home and I want to measure, let's say, the length of my curtains, right? I'll probably take a measuring tape and use inches. That is an imperial or English unit or British unit. But in lab, we do not use imperial units. We use the metric system and standard units. So I will mention both the English units and metric units when going through all of these. But remember, in lab, we want to use the metric system. So one of the easiest things to measure in lab is probably length. The standard unit that we use in lab is the meter. A meter is slightly longer than the English yard you and I know of. A meter is about 10% larger than a yard. as stated there. You would use a meter stick to measure things in yards, or in lab where we're usually working with smaller objects, we could use, like a ruler and measure things in centimeters, which is just a smaller unit of a meter. It's still a centimeter is still related to the standard unit meter, and we'll talk about that relationship later. Um, the next the next measurement that you might make in lab would be volume of, say, liquids or something. So the standard unit of volume is a liter. It's slightly larger than a quart that you and I might think of. There are 4 cups in a quart to get your mind wrapped around that. And so a liter is just slightly larger than a quart. So the measuring tools that you might use to figure out the volume of an object would include a beaker, where there are volume markings on the beaker, a graduated cylinder, or a pipette or a burette. So in lab, a liter is pretty large. It's 4 cups. It's basically a quart. That's a lot of liquid. So if we're working with smaller amounts of liquid, we will actually be measuring things in what is called a milliliter. So again, a milliliter is related to a liter by just a factor of 1,000. So in lab, you'll be measuring things in milliliters. So this relationship, 1 milliliter equals 1 centimeter cubed, is a very important relationship to understand. So we just said liter, the liter unit is the standard unit for volume. So that's 1 milliliter. Milliliter is a way to express volume. Another way to express volume is to take some type of length and cubing it. So 1 milliliter is equal to 1 centimeter cubed. So 1 milliliter is equal to a cube that has a 1 centimeter side on all of its sides, right? That's 1 centimeter cubed. So the volume in a 1 centimeter cubed is also equal to 1 milliliter. The metric system is very useful like that, where we can draw a lot of relationships like this because of the base 10 system that the metric system uses. So the next type of measurement we'll talk about now is mass. So you will take the mass of objects on our balances in lab. The standard unit within the scientific community to convey mass is the kilogram, kg. 1 kilogram is about 2.2 pounds. Pounds is our imperial unit, but remember in lab that we use the metric system, so kilogram it is. We're typically not measuring things that are more than 2 pounds. We're usually working with a small amount of chemicals or powders or crystals or whatever. So we actually use just a fraction of the kilogram. So we typically measure things in grams. There are 1,000 grams. 1,000 grams in 1 kilogram, and we'll talk about the prefixes, what the prefixes mean with the metric system. But it's nice that it's all base 10. So for example, if we were to do an experiment with a nickel weighs about 5 grams. If we would weigh this nickel in kilograms, it would be a really, really, really small number. 5 is a nice number. All right, so the types of tools that you'll use to measure small objects like this include the top loading balance. That's what you'll use in lab. So this is what a top loading balance looks like. A top loading balance only goes out to 2 decimal places. All right, like you see here, that this balance reads 5.01. So that top loading balance only goes out to 2 decimal places. Or an analytical balance. An analytical balance is enclosed. And you actually have to put your object in through the side and close a door. And an analytical balance actually goes out to 4 decimal places. All right. So did you notice on the last slide that I tried to avoid saying the word weight when talking about mass and measuring objects on balances? I tried to avoid the word weigh. So what is the difference between mass and weight? Weight has to do with gravity and how an object is pulled down, the force an object exerts because of gravity. Mass and weight are the same on Earth because they're calibrated to be the same value. It takes weight takes into account the our Earth's gravity, 9.8 meters per second squared. But if you were to take the same object with the same mass onto the moon, its mass would not change, right? The mass of an object, the amount of stuff in it does not change, but the amount of force exerted on the object because of like a, let's say, reduced gravity like on the moon, its weight would be different. So an example, Neil Armstrong, when we blasted him off on the moon, to the moon, his weight did not or sorry, see, I'm already mixing them up. His mass did not change drastically. He was still the same sized man on the earth versus on the moon, so his mass did not change. But his weight, in fact, did change. So his weight on the moon, let's say he weighs 200 pounds on Earth, he would weigh about 33 pounds. He would feel like he weighs 33 pounds on the moon. And so that's why he walks very funny on the moon, because now his muscles, essentially, they're exerting the force thinking that his muscles are moving a 200-pound man, but in fact, because of the less weight and less force on his muscles, he has to get accustomed to walking in a place where he has less weight. See how I didn't say mass? His mass is the same. He's still the same size dude. It's just his weight and how gravity is exerting on him is now less and different. Okay, so in labs, typically we talk about mass, but oftentimes we'll say, okay, go weigh that, right? When we mean, hey, take the mass of this object, but we might go say, hey, go weigh that. So let's talk about another type of measurement you can take, temperature. You should be taking your temperature every time you come to campus for OSU's health and safety. Those thermometers that OSU gave us in those welcome bags, I think they only take temperature in Fahrenheit. But in lab, we will be using the standard unit, the metric unit of temperature, and that is Celsius. We still call it a degree, so it's degree Celsius, just like we say degree Fahrenheit. Temperature measures the amount of heat energy present in a sample. The Celsius degree is larger than a Fahrenheit degree, so like the change between 22 degrees Celsius to 23 degrees Celsius, you will feel more of a temperature difference. You might feel comfortable at 22 degrees Celsius, that's around room temperature, but you might get really, really hot at 23 degrees Celsius versus, about room temperature in Fahrenheit is like, I don't know, 70 degrees Fahrenheit, and you might get really hot at 71 degrees Fahrenheit. See, I run warm. I get too cold. I like to be warm. I like to say I'm a diesel engine. I run hot. So the measuring tools that you use to measure temperature includes a thermometer. There's lots of different kinds of thermometers. So this outdoor thermometer, the red liquid that you see here, is just a colored alcohol. Hopefully you don't see mercury thermometers anymore, although mercury thermometers are very good for taking accurate temperatures. And extreme temperatures, they're not super safe because of the mercury involved and glass thermometers being easy to break. And you've also seen an influx of infrared thermometers. So those thermometers use infrared light to measure the amount of heat energy present in a system, and it can spit out a number temperature to you. So the last type of measurement you may take in lab is time. So thankfully, the metric unit for time is the same as what we use now, and that's the standard unit is the second. So you may use some type of measuring tool to measure time, and that might be a stopwatch or a stopwatch app on your phone. Great. So let's work through these learning checks and make sure that everyone is paying attention. So for each of these following measurements, indicate whether the unit describes either length, mass, or a volume. All right, so all we have to do is look at the unit. We don't even have to read anything else, but we will. A bag of onion weighs 2.6 kilograms. All right, so the word kilogram, the unit kilogram, tells us that this is a unit of mass. But this phrase also say weighs, so that's kind of a giveaway too. All right, the next one. A person is 2 meters tall. Is that high? 2, 6. That's like over 6 feet. So that's pretty tall. All right, so 2 meters tall. So that would be, since the unit is a meter, and meter describes length, that is length. A medication contains 0.50 grams of aspirin. So again, let's look at the unit. Remember, with all of these measurements, every measurement always contains a number and a unit. All of these have numbers and units. So just look at the unit right after the number. So medication contains 0.5 grams of aspirin. So gram is related to kilogram. So this would be a mass unit. And then last, a bottle contains 1.5 liters of water. So liter is the standard unit for volume. So this is a volume measurement. All right. I want to just draw your attention. I just kind of thought of this real quick. What if this phrase, a person is 2 meters tall, what if they didn't put the unit? Let's just say, like, you were talking to your friend and they asked you how tall you were, and you said, I am 2.0 tall, right? Your friend would have no idea what you're talking about because you didn't include a unit. Are you, 2 feet tall? Are you 2 inches tall? Are you 2 car lengths tall? Are you, 2 whatever tall? No, so you really need a unit to properly convey different measurements to people, because as long as we all understand the same unit, all right, we can convey precise numbers to one another and understand, how big or small you're trying to describe something. All right, so that's the importance of units. All right, one last learning check for this section before we move on to the next one. So identify the metric measurement. So remember, when we talk about metric, we're talking about our standard units. No imperial units. Standard units only. So John's height is 1.5 yards. Yard is an imperial unit. Bad. 6 feet. That's an imperial unit. Bad. So he is 2.1 meters. Meter. That's a metric measurement. Great. The race was won in 19.6 seconds, 14.2 minutes, 3.5 hours. So if you remember from that slide, the standard unit is seconds that we use. So it's seconds. All right. A mass of a lemon is 12 ounces, kilograms, pounds. So again, pounds is imperial. Ounces, I think, are also imperial. So kilogram, there's our metric unit. All right. Temperature is 85 degrees Celsius, 255 Kelvin, 45 degrees Fahrenheit. So we know Fahrenheit is imperial. We haven't talked about Kelvin yet. That is not the standard metric unit. So here, 85 degrees Celsius, that is our metric unit.